All right, well, this is going to be section 5.7, um, algebra, algebra 2. We'll cover analyzing the graphs of these quadratic functions. So just a little bit different way of looking at the equation. Normally we're used to our standard form, okay, which is the ax squared plus y equals ax squared plus bx plus c. And that's kind of the form we use all the time when we solve equations and even when we graph, we kind of just threw that in the calculator. Um, there's an alternate form here, which has some good qualities to it that we'll look at in a second, called vertex form. And what it is, it's just kind of a different way of writing things. You still have the a value in there, but then they kind of have this. They introduce this h and this k. Okay, and it's a times x minus h, the whole quantity squared, plus k. And and what it does for us and why it's kind of helpful is that you can find the vertex of the graph very easily. Okay, this h and this k, they are actually the coordinates of the vertex. So if you were going to graph something, and let's just say you wanted to have like a quick idea of what it looks like, you didn't have a graphing calculator or something. If something's given to you in vertex form, you'll know that the coordinates of the vertex are going to be those numbers, whatever h is and whatever k is. So you kind of know like where the center of the graph is just by looking at the equation. You don't have to do the negative b over 2a thing that we did with standard form earlier. So I mean, that's one kind of use. So a couple other things that this form does for us. I just want to get into a little bit of detail, and then we'll kind of practice going back and forth between the two forms. Um, in this form, in vertex form, the a is basically the same as it was before. If we remember, the a told us if the a value was positive, that meant that the graph opens upward. Okay, and that's still going to be the case. If the a value is negative, just like before with standard form, the graph opens down. Okay, so that the a is basically the same as it was before. Um, what the h and the k do, like I said, they are the coordinates of the vertex. And basically what ends up happening is, the way I want you guys to think of it, is that h is going to be a horizontal shift. Okay, it's gonna take the whole graph and shift or slide it left or right. Okay, horizontally. And k is going to be your vertical. It's going to move the graph up and down. It's a vertical shift. Okay, so if those numbers aren't there, if they're zeros or something, then your graph is going to be centered at the origin. But if there's an h in there and if there's a k, your graph's going to be moved around a little bit. And we'll see more of those as we go back and forth between the forms and a little bit later in the section. But that's kind of like a brief overview of what this form does. So we'll leave it at that for right now. Let's kind of focus, let's look at, how do we go back and forth? If you're given something in standard form, how do you change it? Why would you want to change it? And that kind of thing. So a couple examples. Let's convert this. It's given to us in vertex form. Okay, it looks like you can tell it's vertex form because again it has the x minus something in parentheses squared, and then it has that plus k on the outside. It just doesn't happen to like show an a value, but again, we know if there's nothing out there that the a value is 1. So in this case, the h would be actually negative 1. Okay, and we'll talk about why h is negative 1. It looks like it's positive 1, but notice in the formula there's a minus sign. Okay, so we are actually doing x minus a negative 1 to make it become x plus 1, and we'll talk about it. The k is the easier of the two. The k kind of just lines up. The k value is the 3 at the end there. So what this would do, I guess before we change, we can mention real briefly without too much detail. The vertex of this thing, if we were going to graph it, okay, and that's not the goal, but if we were, again, in here, this tells us that we are shifting the vertex from 0. It's getting shifted to the left one. Okay, because our h again is negative 1. The k on the outside tells us we are shifting up 3. Okay, so this vertex is actually left from the origin again, left 1, up 3. the vertex of this graph would be here at negative 1, 3. And then the graph just does some sort of opening up kind of thing because the A is positive. But again, more on that later. That's just kind of a real quick, what do these numbers mean kind of thing. But our goal for now is to write this thing in standard form. Okay, so we want to take the form that they gave us and write it in the form that we're more used to. Okay, so this one's the kind of thing where you just kind of do what you would expect. Like, we don't really need anything new. We just want to like multiply it out. Okay, we're going to multiply it out. And what I mean by that is when you see something squared, it means take that thing times itself. And we're just going to FOIL that and kind of combine all the like terms, and it's going to end up in standard form. We'll see. Okay, so let's do the FOIL, distribute everything out. So again, we'll do the x times x to be x squared. X times 1 is plus x, plus another x, plus a 1, and then we got a plus 3 sitting out in the end there. And just kind of combining all these, cleaning it up, and then it's going to give you standard form. So that's kind of the easier of the two. Just actually multiply it out. Combine terms there to be a 2x. We can combine the 1 and 3 to be a 4. So that's going to be our standard form. Okay, so it's the same graph. Okay, it would look just like the one we drew up here. Oh, don't know why that's way over there. It would look like the one we drew here. It's just kind of written differently. Okay, and if we were to check it by graphing in the calculator to make sure that those two things actually are the same, they should produce the same graph. Okay, so let's do that. I'm going to pull up the calculator and give it a look if you guys have one on you right now, or you can just watch. But we'll kind of prove that these things are the same, just written differently. Okay, so let's take a look at the calculator again. What I'm going to do is type in the answer that we just got. Okay, I'm going to be comparing this to what the original problem was. And I just want to show you that they're equivalent to each other. Right? We just kind of did some algebra on it to get the new answer. So in the calculators, I just went into the y equals screen. I typed them both in. There's the vertex form up top, and then our standard form on the bottom. And when you press the graph button to make sure they line up, so you see there goes the first one, and it's actually graphing the second one like right on top of it. We can't even see it, so you just see the one graph because they're both the same. So kind of a better way to verify that they actually are the same. Look at the table, and you can tell all the values match up. So y1 was our first form, y2 was our second form. They're all the same. Okay, those equations are equivalent, just written in different forms. Okay. Okay, so that's changing something into standard form. Now it's a little bit trickier, or it can be, to change, into vertex form. So if they give us something in standard form like we're used to, and we want to rewrite it in the other form, let's say we want to know what the vertex is without having a graph or not having to do the negative b over 2a and plug in and everything. Okay, what we can do, we're actually going to complete the square. So that's kind of one other reason that we did that last section or a couple sections ago. It solves equations, but it also has some other uses. Okay, and here's one of them. So let's do it. It's going to be a touch different than what we did, but it's like kind of the same basic premise. So again, think about x squared plus 8x. We need to figure out what the perfect square needs to be. And I'm just kind of bringing the minus 3 down for now. And then we're going to have to balance out whatever we add. So the only difference here, the negative 3 or the minus 3 is not going to the other side of the equation like we did when we solved the equations. But now the process is going to be similar. We're going to look at, I want to figure out what number should go here. So I look at the b value just like I did before. I take half of it and I square it. So this is nothing new. So half of the 8's 4. When we square that, we're going to get a plus 16. Okay, but here's now where you got to be a little careful. Don't rush through this. We just added 16. Okay, we are on the same side of the equation. I need to balance that out. I need to subtract the 16 to balance that out. Okay, we're not working on the other side of the equation where the y is, on the left side. I'm just going to keep that minus 16 to balance out what we just did. Okay, and now basically what it boils down to is factor this into a perfect square like we've done before. That is x plus 4 squared, just like before. And then you combine your two numbers out here. Negative 3 minus 16 is a minus 19. And now that is vertex form. Okay, so this would be our answer, vertex form right there. Okay. So it's a matter of completing the square. Okay, let's do one more. We sometimes have a little bit more complicated problem when the a value is not 1. Okay, so I want to be real careful and take this one real slow. It's going to be the same deal though. We want to take the equation as is. Okay, right now this is standard form, the way that they gave it to us. And if we want to change it into vertex form, again, this is when we're going to use completing the square just like we just did. Okay, but when there's an a value in there, you got to be a little careful. What you want to do is actually factor that out first. Okay, so I take the negative 2 out. It leaves me with x squared. Taking the 2 out of that term leaves me minus 2x. And then we're going to leave a space here. We're going to figure out what the perfect square is. We're going to complete the square. And now I did not touch this plus 2 yet. It's not part of the factor. Okay, it's not in the parentheses. So the negative 2 that I took out here has no effect on it. So I don't have to divide this by 2. I'm going to leave this as is. Okay, but what we're going to do is leave a space to balance out whatever we're adding into the equation when we do complete the square. Okay, so just be kind of careful when we do this now. When we're completing the square, again, I'm just looking at this b value right here. Okay, and I take a half of that, so that's a negative 1, and when I square that, it's a positive 1. Okay, so now, you might think, well, we need to subtract 1 in this other blank over here to balance out what we just did. Okay, I'm talking about over here. Do we want to subtract 1? We actually don't, because what is this? The 1 that we added is actually getting times by something. It's getting multiplied by negative 2. Okay, so we are really doing like a minus 2. So to balance that minus 2, we need to add a 2 here. Okay, so again, when you factor an a value out, okay, just take it slow. When you factor an a value out, when you go to complete the square, you're not just adding that 1. You are adding whatever this is times that 1. Okay, so what we have, this negative 2, I'm just going to bring it down. Okay, the thing in parentheses will always be factored. In this case, it's x minus 1 all squared. And then combining our two constants out here, we get a plus 4. That is now vertex form. Okay, so again, a little tricky. You got to just kind of take it slow. And and really watch the details on these. Okay, so that's vertex form. Okay, and last thing in the section, we want to be able to write the equation of a quadratic when we know the vertex and we know another point that is on the graph. Okay, so we know the vertex of this thing is 1, 2. We know it goes through the point 3, 4. Okay, so just to kind of get a little visual, again, not mandatory to graph this or anything, but just so we can kind of see what we're dealing with. 1, 2. So the vertex is at 1, 2. There's my vertex. And another point on this thing is 3, 4. Okay, so the vertex is always the minimum or the maximum, so we know it's going to go up. We know these things are symmetric. It's going to look the same on both sides. So something like that. Okay, again, not super important what the picture looks like, just to visualize it. Okay, and here's where vertex form is going to help. We're going to use vertex form. X minus h all squared plus k. Okay, and what we want to do is just start plugging everything in. Okay, the vertex up here was at the point 1, 2. That's your h and your k. It's like a special point. It's not just an x and a y, it's a special h and k. The other point, okay, this guy up here, that's the x and the y. Okay, so the vertex is like a special point, hk. Any other random point, xy. So let's plug in everything we know. Okay, if you remember doing this in linear, when you plugged into y equals mx plus b, it's kind of similar here. The y value we're plugging in is 4. Okay. The a is the thing that we don't know. That's the thing we're going to find. Okay, the x we do know is 3. Minus h, which is 1. That all gets squared. plus k, which is 2. And all we really got to do is solve this thing for a, okay, and we can find our equation. So let's do some simplifying here. We got 4 equals a. The 3 minus 1 in parentheses is really a 2. That's getting squared. We still got this plus 2 on the end. Okay, 2 squared is really 4, so that's like a 4a plus 2. So I just squared the 2 here, right? 2 squared is the 4 times a. And now we have a little linear equation to solve for a. We're going to subtract our 2 and finally divide by 4. Okay, and we'll get our a value. Okay, so our a is 2 over 4. If we reduce that, a is 1/2. Okay, that's our a value. That's what we need to write the equation. Okay, that is not the final answer, but that's what we need. Okay, now all we need to do, we're basically done here. We're going to plug in the 1/2 in for a right here, and we're going to plug in what the vertex was. Okay, we are not plugging in for x and y. Okay, those need to stay variables. When you write the equation of something, we don't plug in for x and y. So all we're going to do is go back to our vertex form. Y equals, we know a is 1/2. X must stay a variable. Okay. H and k we already knew were 1, and k was 2. So that would be the equation in vertex form, okay, of the graph that we had. So it's really just a matter of finding the a value. We already knew this piece and this piece from the beginning. Once we knew the vertex, -1 and 2. So when they give you the vertex, you kind of know most of those pieces. Okay, those were kind of set from the beginning, right here and here. The only thing we didn't know was a. Okay. Okay, and that is that. We can kind of tell from this graph that it opens upward because our a is positive. Okay. We know where the vertex is from the h and the k, and that's what the vertex form really does for us. And that's that.